Instrument types. The instruments are classified or subdivided into separate classes according to many criteria. It's good to classify the sensors so that we can select the suitable one for us in our application. In active and passive instruments, it's a kind of a classification where we are going to put the sensors in one of these categories, either active or passive. What is active? In active sensor, the measured or the quantity to be measured is not measured direct. It's somehow converted to electrical signal. So power supply is needed in those kind of sensors. Like you see here, power supply is needed to help me to convert the measured quantity to electrical quantity which to be displayed. Like in the petrol tank level indicator. In the petrol tank level indicator here, we are measuring the level. So we are having a float to measure the level, but the float is not giving me the value direct. The float is connected somehow to variable resistor, where the variable resistor is supplied by battery. So now the variable resistor is going to change as the level of petrol is changed. Means when the float is going up or down, the value of variable resistor will change, which will make variable voltage on the output. So the output here will be voltage, is not going to be level. But the voltage on the output is proportional to the float. That's why we call it active. So in active, usually we have power supply. That's what I explained in the previous slide on the petrol tank indicator. How about passive instrument? In passive instrument, the quantity is directly measured without converting it to electrical. Like if you look here, the pressure of the fluid here is measured by the changing of the piston position, and the piston, this piston is connected to this pointer. As the piston level goes up or down, the pointer is going to change its position. Means when it goes up at this point here, let me just change the get the pointer. When the piston is going up, it's very clear that that side or this side of the pointer will go up. That means this side will go down. So the signal or the pressure is directly measured without converting it to electrical. We call this kind of sensor or this class of sensor as a passive sensor or passive instrument, where no power supply needed for this kind of sensors. Nil type or deflection type sensor. This is another kind of a classification where we can classify the sensors as nil type or deflection type. Deflection type is having deflection which will show, deflection means the pointer will change its position. This is the deflection we talk about here. So the position of the pointer will be proportional to the change of the measured quantity. So I need value here. I need the pointer to move. I need the pointer to deflect. But in nil type, in the nil type, we don't care about the value. In nil type here, we don't care about the value. We are having certain reference as you see here. I'm talking about this reference. So what we care about, whether we reach to that reference value, which we call it the nil position, we reach to it or not. So once we reach to it, it's considered that the sensor is feeling the quantity. I don't care about the value measured. I care about whether I reach to this position or not. Analog and digital instruments. Another kind of a classification, we can put all the sensors or all the instruments under category of analog or digital. What is analog first of all? Analog is the instrument is producing analog signal on the output proportional to the measured value. As you see here in this figure, We are having here thermocouple. Thermocouple means heat sensor, which converting the heat to electrical signal. So the heat measured at this side is measured by the sensor, and the sensor producing this signal. So this is the signal which we call it analog. Analog, it's changing as a function of time. We are having a huge number of values here. Every moment there is value. That's why it's analog. So here we call this kind of sensor or this kind of instrument as analog instrument. In digital instrument, the output comes in discrete step, not a continuous step as before. I mean, the signal is going to come in a discrete steps with finite number of values. To understand it, let us look at this example. In this example, he will tell, or we will measure a speed of motor by the help of cam. Okay, so to understand this better, let's assume that this is the motor, this is the shaft. So here we fix a cam. This cam is this one. So now when the cam is reaching to this arm, the arm will be pushed up from here. So if it's pushed up from here, it's going to come down to close this contact. With the closure of this contact, a signal will go to the counter. So counter will count one step ahead. So if you notice here, there is no continuous signal to be measured. No, whenever the cam reach to the arm, one step ahead to be counted. From there, we will analyze the signal to get the speed of the motor. Indicating instrument and instrument with the signal output. Another kind of classification for the instrumentations where we can put the instrument in a form of instrument for indication and instrument to get signal on the output. The instrument for indication is the instruments which will producing indication signal in the form of audio or visual on the output. Means the output of the sensor, when the signal is measured, there will be an audio signal on the output or visual signal on the output, like alarm or light or something like this. But this instrument with signal on the output is similar to what we discussed earlier. It's for a purpose of measurement, means we need signal on the output to be measured. A smart or non-smart instrument. Again, all the instruments can be classified as a smart or non-smart. A smart instrument means the instrument which comes with microprocessor, where we can program the sensor to do certain smart action by the help of the microprocessor. So any instrument comes with microprocessor, we consider it as a smart sensor because we can program it to act smart in a smart way. The rest of the sensors is considered non-smart. I mean, if there is no any computerized system in the sensor, it's considered as a non-smart sensor. That's all for week 1 material. I hope everything is clear. Thank you.